So I'm going to be talking about, as you all know, GeoDjango, as I like to call it, the world-class geographic web framework. And here's where I'm going to be going today. I'm going to be giving kind of like a very high-level overview, an introduction to some GIS basics, because those play an important role later on in some of the limitations. So when you're trying to blame me for why something doesn't work, it's really a function of something else. I'm going to go briefly over the installation. I don't have time to go into all the nasty details about it. I'm going to cover some of the interfaces to geospatial libraries that GeoDjango has, and discuss the bulk of the presentation. We'll be discussing what's all the goodies inside the model and database API. And we'll be going a little bit through some utilities, discussing the admin a bit, geofeeds and sitemaps, and kind of where I'm going to be going from here with GeoDjango, and take some questions and answers. All right, let's start from the beginning. Geo what? All right, GIS, for those who aren't familiar with, stands for Geographic Information Systems. And there's a good quote on one of the blogs saying, if you ever want to end a conversation with a developer, talk about character encodings or coordinate systems. And I'd say that's pretty much true. So there's standards, data, and coordinate systems are foreign to most developers. They were to me when I started doing this stuff. And it all boils down, the fundamental issues all boil down to that maps are flat, the world is not. And seriously, that's where a lot of the problems lie from. Okay, so now we're going to go head first into talking about coordinate systems. They're a way of representing location. And like I said earlier, they're analogous to Unicode, and essentially they give context to the spatial data. So that's very, very simplistic view here. And specifically, in general, there's two types of coordinate systems. We've got geodetic or geographic, and the coordinates are in angles, and which are in reference to a datum, which is an ellipsoid model of the Earth. And then there are also projected coordinate systems, which are a way to represent the curved surface on the Earth onto a flat surface. And they usually they only cover, say, like South Texas or the whole of North America. And with projected coordinate systems, you can actually have units that are not angular. In fact, so you could have like units in feet or kilometers. But the problem is when you do project something, you always have a compromise and distortion, and there's different types of conic projections, cone projection. There's a whole bunch of different types, and they have different trade-offs on what distortion you want to do. Some are better for distance, while others are better for area, et cetera. So this is kind of like laying the groundwork for where we're going. Standards. There's the Open Geospatial Consortium gives standards for the interchange of spatial data. And so they're kind of the big boys. And the standard that GeoDjango adheres to is the Simple Feature Access for SQL, also known as SFS. And it's a standard for accessing spatial databases and performing queries on a spatial table. And part of that specifies how you represent geometries in a textual form, and that's known as well-known text. In kind of an error omission, they also named the textual format for coordinate systems well-known text as well. So there's two types of WKT, one for geometries, one for coordinate systems. But whenever I refer to it from here on out, it'll be to the geometry aspect of it. And there are also KML, GML, WMS, and WFS are other standards, but I won't really be covering those. KML used to be owned by Keyhole, which was acquired by Google, and then Google assigned all that to OGC just this year, in fact. So they're playing nice with the standards committees. All right. So in the simple feature specification, there is a set of geometries. We've got point, which is just a simple XY point, a line string, which is a sequence of points, a linear ring, which is still a sequence of points, but they're closed. In other words, the first point is the same as the last point. And finally, a polygon in its simplest form is one linear ring with the areas enclosed in it, and you can have one or more, actually zero more inner rings that you can specify. So it all boils down to these simple shapes. And in addition, you can also have multiple geometries in the collection. So if you have a multi-point, you can stick more than one point in it. Same with line, string, linear ring, and polygon. And finally, there's the general placeholder geometry collection, which you can stick point, line, string, or polygon into it, any number of them. So those are the building blocks here. So what exactly is GeoDjango? Well, the top one shouldn't have come in so quick, but whatever. It interfaces to popular spatial databases, including PostGIS, Oracle, and MySQL. And MySQL's a pseudo spatial database. It's missing a lot of the, it's missing almost all the functionality to be standards compliant, but it's got enough there to get you by and wish you had PostGIS. And as well as provides interfaces to the Google, Geos, and libraries, and Proj.4. There's no direct access to it, but it's the open source library that does coordinate transformations from one system to another. So you can transform from latitude, longitude, and WGS84 to a projected coordinate system and something else. So GeoDjango handles all that. And then we've got ways to serialize out to web mapping systems through KML, GML, WKT, GeoJSON, and GeoRSS. And you can feed it to your favorite mapping platform of choice, my OpenLayers or Google Maps or Earth. My preference, I like Google's base layer, but I really like OpenLayers a lot. So how did I do this? What the heck am I doing here? I decided to rip off Adrian's site, Chicago Crime, for Houston when I moved there for law school. I got really, really bored in evidence class, and that's where I did a lot of my coding. And it reflected well in my grade, too. I chose Django independently. I didn't know that Adrian had written his site in Django, and that's when I knew I was onto something, and I contacted the creators at PyCon and Jacob in 2007, and just this, the branch was merged in 2008. All right, so since you guys just came back from break, we're gonna do some fun stuff right now. I'm gonna give you basically a crash course on how you geo-enable your models. Basically boils down to what's in yellow is what's different from normal. So instead of importing from Django.db import models, you import from Django.contrib.gis.db. And that kind of pattern follows for almost a lot of the additional functionality. For example, the geo feeds or the geo sitemaps. There's gis.sitemaps, gis.feeds, for example. And the models has everything else that the normal Django models has, but then it has the additional stuff, the GeoManager as well as the geometry fields. So in this one here, we're doing a multi-polygon field, since some zip codes can actually be more than one polygon. And we put the GeoManager on it and just have a string representation there. And in our admin.py, we have, like I said before, instead of importing from Django.contrib import admin, you do from .gis. And here I have, it's called OSM GeoAdmin, which stands for OpenStreetMap. And because of a restriction in Google Maps licenses that can't be used on non-public sites, we're using a free data provider here. And you just register it like normal. So I'm actually going to hopefully show you. Whoa. All right. Same as my web browser went down. Sorry. Okay, and so when you have the GeoAdmin, we're in, I think, 99043. All right, whatever. So you can actually manipulate the geospatial objects. My mouse is sticking here. Right inside the admin. So you actually get using OpenLayers, you can, I have to apologize, you can actually, wow, that's a big polygon. Wow, this is not a GWiz demo. We'll come back to it. All right, so I'll go to some sites. Like I said, I created Houston crime maps here. Another big site, another big uptake of GeoDjango has been Florida newspapers, and this is an example of the Backyard Post, which is the Palm Beach Post. They've been using it for real estate listings. Similarly, a few weeks ago, Matt Waite launched the Tampa Bay Watch, and it's a way to explore right now real estate, but soon other things for the Tampa Bay area. And this year, Burning Man laid out the playa using GeoDjango, and also served up their data to, say, Flickr and other services using GeoDjango as well. And this is where Flickr had integrated it in and their geotagged photos. So now we're going to go briefly into the installation. I'm not going to delve into here. In short, it builds character. The minimum requirements are Python with C types, 2.4 with C types. We don't support 2.3. And a spatial database right now. Like I said, PostGIS, MySQL, Oracle, XE is not supported. And geospatial libraries. And at the very minimum, everybody needs Geos. And then if you're running PostGIS, Proj is a requirement anyway. And because I rely on some of the relatively new features, the relatively new geospatial libraries, there's not a lot of binaries available. And everything that you can think of in normal open source software and open source geo software is kind of like always 2 years behind on getting stuff packaged up and nice. And so I'm trying to really push to get more binary packages. This is the biggest source of grief for people because they have to install from source and it drives them nuts. So I have very detailed instructions. They're getting more and more filled out. And it's very, it's not so bad. You guys are all experienced. All right. Now we're going to go on to the cool stuff, the geospatial libraries. So the big ones that I have interfaces for are Geos, Scoodle, and GeoIP. I'll explain what those acronyms mean. Why did I do this? Because a lot of these already had interfaces to Python, but they were they use Swig, which in some use cases is very good, but it could be very temperamental and make installation 9 times more of a nightmare than you can imagine. So I decided to ditch the Swigs and use C types, which recently became standard in Python 2.5. And because we're using the C APIs of these libraries, cross-platform compatibility is great. So I've personally tested on Linux, Windows, Mac, Solaris, just to name a few. Oh, sorry, let me go back. Explain. The OSGeo is the kind of umbrella organization, kind of like the Django Software Foundation for open source geographic stuff. And all of those projects, except for the MaxMind stuff, are open. They're kind of like, I'm not just picking out little tiny libraries out there to interface with. These are the standards of the open source geographic. All right, so Geo stands for Geometry Engine Open Source. It's a C++ port of the Java topology suite, and it's a geometry engine. So here's an example of working with it. Here I'm instantiating the same point 4 different times, but you can use WKT, GeoJSON, there's a caveat, you need Goodle for GeoJSON, hex, which is just a binary form of WKT, as well as I actually have constructors for each of the geometries. So linear string, you can give it a sequence of 2 tuples, like I did in the polygon constructor. So there's a lot of ways you can interface with these geometries. And here I'm doing a contains operation. This is not going to the database at all. It's actually going right to the C library. So we're saying, does this polygon contain the point? True. Does the polygon intersect the point? True. And is the polygon within the point? If you think about it, can you fit a polygon in a point? No. So false. And polygon here is just kind of a big triangle and the point's in the middle. Also, I made these libraries Pythonic, so like the string representation prints out the WKT, and then I put on other methods here, for example, KML, and it's not indented like that, but you have those attributes right there. Okay, Goodle. The Geospatial Data Abstraction Library is like the Swiss Army knife of geodata formats. It handles more than anything I know. Even commercial stuff pales in comparison to what this can do. In fact, the closest commercial vendor just open sourced their stuff recently to try and compete or integrate with them. And here's an example of using something called data source. And data source is a way of exploring geospatial data formats. Now, the biggest, I guess what you call the de facto standard almost for spatial data is called shapefile. And here I'm just opening up a shapefile, pulling out the first layer of it, and saying, okay, show me what fields you have it. And by the way, this shapefile is about a 700 meg shapefile for all the zip codes in the United States, and that's kind of what I'm going to be using as my template for what's going on here. And here I'm finding out what the geometry type of the shapefile is, how many features are in it, and then you can even, like I said, you can be Pythonic and go iterate through each feature in the layer and pull out whatever information you need, which comes in handy when you need to write some custom importation scripts, but we'll get to that later. Also, Google has its own geometry implementation and has a spatial reference abstraction. So I'm going to be focusing on the spatial reference one here. Here I'm creating a WGS84 spatial reference object, a NAD83 one. These are just different coordinate systems. And here I'm saying I have a point, and this is actually for right out there in the patio. And I'm specifying it's in WGS84, and this is the point. And then I can transform it to a different projection. In this case, 900913. I didn't come up with that, but it's supposed to be an anagram for Google. It's called the Google Maps Mercator projection, which is what is kind of like the internal projection that Google uses on their maps. And it's a way that you can overlay data on it. It's a different way without it. I'll explain that later. So here, the point has been transformed from this geographic point to this projected point that's in meters instead. Next is the GeoIP. So MaxMind provides data sets for IP allocation around the world and updates it and releases open source versions of it. They have a library, or they have a Python library, but it was GPL. And it was actually really easy to, using C-types, to just whip up this BSD license library. And so here's kind of an example of its use. You do need to make it this easy, in your settings file, you specify a data path, or you would actually manually pass it into the class instantiation there. And then you pass in a domain name or an IP address, or a fully qualified domain name or an IP address and a string, and it'll return information for it. And then I even have a shortcut for just giving you a geos geometry there. All right, now we're going to be getting into the meat of everything. All right, as we covered before, it's only what's in yellow there is what's really changed, what's different. So you're going to be you import everything from django.contrib.gis. So you've already seen this. So now here's what the SQL looks like. So when you actually do manage.py SQL all, or when you do syncdb, this is what happens. So and with PostGIS in specific, I had to add extra management hooks because the actual standard specifies that you don't add geometry columns in the table definition. You actually have to call a stored procedure afterwards. So after the table is created, then I have a hook, a newly created hook that went into Django 1.0 to add this extra SQL here afterwards. So you call the stored procedure, do all the other stuff that you would normally do, like setting it not null, and then creating an index, a spatial index on it. And spatial indexes are different than textual indices because they're bounding box based. So they take little squares of all the geometries, and that's how it can fastly compute how the relationships work. And here's an example of some MySQL there. And you notice there's no index creation on this. And this is because my database has NODB turned on. And MySQL is one of its many faults. It doesn't support spatial indices on NODB. You can only use MyESAM. So it's, if you want transactions and geospatial support on MySQL, you're kind of out of luck. So these are the geographic fields here. that we support. So like I said, we have point field, line string field, polygon field, multi-point field, multi-line string field, and even kind of a catch-all geometry field, which can handle any geometry. Now, you also, like normal fields, these also take keyword arguments. And the most important one is SRID. And you use this to specify the coordinate system used by the field. It corresponds to a table that's mandated by the standard called SpatialReference, and it's indexed by an integer called the SRID, and it contains all the transformation or whatever information that is needed for the spatial database to know what coordinate systems your geometries are in. By default, I use 4326, which is the most common coordinate system in use today. It's what's used by GPS receivers. It's what's used by Google Maps. It's what's used by almost everything. However, because it is because the units are in latitude and longitude, that can, if you keep the default, it can have consequences later on. So you have to really think about, what my needs are here with, do I want to try and cover the whole world, or if I'm only handling stuff in North Kansas, then should I use a projection system for North Kansas instead? That is probably the most important choice that you make with GeoDjango. And there's also an option that you can turn off the spatial index creation if you want. By default, it's on. So, all right. GeoManager. GeoManager is where all the magic happens, where the spatial SQL is constructed, and that's what Malcolm was talking about in the previous talk. GeoManager is just a kind of adds on whatever GeoQuery set methods I have, as well as when you call the get query set, it returns a GeoQuery set instead of a regular query set. And without GeoManager, none of this stuff's going to work. So you must have it. And the small catch is that you also need it to query across foreign key relations, even if the model that has the foreign key relation doesn't have a geometry field. So examples speak louder than me fumbling on my words here, but you see this address model here has no geometry field in it, yet we're still putting a GeoManager on it. Why? It makes that query above possible. So when I try and say filter across zip codes that have polygons that contain this point, then it's going to work. But if I don't have the GeoManager on that, then it's going to say can't join on this field. All right, we're going to go into spatial lookups. These are just some examples from the actual standard of geometry relationships. So on the left, we have overlap. So you can see an example of two polygons overlapping. You see where two line strings, how they would overlap. The bolder one is on top of the thinner one. We have the within relationship, where you see what constitutes what's within something else. Polygons, line strings, and polygon points. And also the crosses relationship. Now, all these relationships correspond to something called the dimensionally intersected DE91M model. The words escape me, but essentially they use some linear algebra techniques to find out quickly whether one geometry has this relationships to another. So, I've extended the lookup types in GeoDjango. In addition to all the regular ones, you have all these. This is just the first half. So anything that starts with BB contains and BB overlaps is a bounding box operation. And the difference is, I don't know if you can see here, but pretend my microphone's a polygon, then the bounding box would be the square that surrounds the polygon. So that you would, even if you're saying a point outside of the polygon could still be within the bounding box. So that's what I mean by bounding box operation. And those are the only type of operations that MySQL supports. And I just kind of alias in contains is really BB contains on MySQL. So that's what I'm saying. If you're using MySQL long enough, you're going to want a real spatial database after a while. So we have contains, contain, cover by, covers, crosses, disjoint, equals, exact, intersects, overlaps, relate. And you can see kind of the support on each of these. Same as touches, within, left, right, overlaps, right, left. from here on out, I just have the ones that are on PostGIS only. I've never seen these in any other spatial database. So you can actually say is something to the left or to the right, overlaps. It's these peculiar little relationships that they put in there. And the way these work is they take a geometry as a parameter. So when you're using these lookup types, you're going to be passing in a geometry. And the parameter may be any one of the following. You can use a geos geometry, a WKT string, a string of hex, or a string of GeoJSON, if you have Google, of course. So you can just pass these in, and they'll be converted internally into a geometry. Another cool thing, because I'm lazy, is that we have automatic transformation of input geometry. So if you're querying, if your model's in a projected coordinate system and you just get some point from your GPS receiver, which is in latitude, longitude, and you specify that, then it'll automatically be wrapped in the transformation SQL. So you can use it with any spatial database table as long as that SRID is in the SpatialReference table. So if you don't specify anything on your geometry, then I just assume that you're using the SRID of the field. So again, an example here. I'm using my zip code example, which is actually the live example. And I have 1 point in WGS84. That's the zip code I was looking for, 9443. All right. 1 point in WGS84 and another point in the projection for kind of Central California here. It's called NAD 83 California Zone 3, with the units are in survey feet. So you notice in the first one I didn't specify an SRID because it's the actual model field is in WGS84, whereas in the other one I'm making sure to explicitly say, hey, this SRID is for the one for California. And so I'm doing my query here where I say mpoly __ contains equals point, and same with the other one. So you can also, like I said, you can also have just a string of WKT there or hex or JSON. Distance queries. These are probably the hardest part and one of the most important parts of this. And this is where I was saying the world is not flat, or the fact that fact is what makes these complicated, because when you're using a geographic coordinate system, the closest point, the shortest route between 2 points is not a line because you're on a sphere. It's an arc of a great circle, and that's what makes calculating distance on a geographic coordinate system really tough, or not really tough, but it makes it more difficult. Robert Koo, he's from New Zealand, came up with this excellent module, contributed this excellent module called Measure, and it includes an object called distance. And it really eases the conversion between units of measure. So here I'm instantiating a distance object saying that the initial units are feet. So I have 5,280 feet. So when you access the miles attribute, you see that's exactly 1 mile. And if I want to see what the kilometer attribute is, I just do distance.kilometers. A little bit off topic, but there's also an area in there as well. When you do GML, it'll attach, you have a little GML attribute on every model that is the string GML representation. And that's an OGC standard. Not very many people outside of city governments and outside of governments in general really use GML. You can also use KML, which is on PostGIS only, and it'll actually when it creates the KML, it'll automatically transform it to WGS84, which KML only supports that. So it takes care of that magic for you. When you use it on the model, on the actual like a geos geometry, it's kind of dumb about that. So I don't do any magic like that. And then on SVG, and then it also has an SVG method, so you can actually get SVG representation too. Measurement methods. We have area, distance, length, perimeter. So all of these, they'll actually attach, for example, area will actually attach an area object on it. So you'll be able to, if it's of course in a projected coordinate system, then you'll be able to get the square units of area for that. And distance is probably be one of the most used ones out of these measurement methods. It'll actually attach the distance object that from the field on the model to whatever the geometry parameter you passed in. And the same limitations apply here as they do in the other distance queries. So length, attaches the length of each geometry, and perimeter, it's also another distance objects attached. We also have geometry operations. So if you wanted to do bulk difference operations, find the difference of one geometry and another, or the intersection, or the symmetric difference, or the union of each geometry field in the query set, you can do that with these. I also have other, I call them geometry methods. Centroid, you'll get the center point of the geometry attached in the centroid attribute. Envelopes, same thing. Centroid's a point, the envelope's a polygon, and a point on surface. You need this one instead of centroid because centroid's not guaranteed to be on the geometry. Point on surface is, and that's another. They're called geometry methods because all these attach a geometry. These ones don't though. Oh yes, sorry, take that back. Scale will, it'll actually, so if you tell it to scale it, if it's a number less than 1, it'll shrink. If it's a number bigger than 1, it'll expand it on the X and Y axis and attach it in that attribute. Same with translate will move the geometry, the X and Y offset that you give it. And transform is going to be another highly used method. It transforms the geometry field to the given SRD. It doesn't actually attach one, it transforms it in place. So when you say transform to 4326, then all the geometries on within the normal geometries on your query set will actually have the SRD of 4326. Okay, as I say, examples speak louder than words. Whatever that means. All right, here I'm just chaining these together like you would normally would. I'm getting the GML, KML, SVG, and then I'm saying getting the zip code. This is for the zip code here in Mountain View. And as you can see, you just pipe out the KML attribute, the GML attribute, and the SVG attribute are all right there. Same thing with getting the centroid, and instead of attaching it to a centroid attribute here, I'm passing in that model at keyword and saying I want to call it center instead. And it's just like any other geometry there. And finally, this is a kind of more of an interesting thing because I'm using those geometries here, I'm taking that zip code and I'm doing something called a buffer operation. So I'm putting a tiny little skirt around it, and then I'm finding all the zip codes that intersect it, and then I'm doing a union operation on it. Except I'm missing the union on that example. Just pretend there's a dot union on that last query set there. And this is another very popular one, sorting by distance. So again, I have my South Texas City object here, and I'm getting the distance to whatever geom I'm putting in, and then you just do an order by on the new distance attribute or whatever you decided with the model at keyword to call it. And then you have these distance the actual representation on each object in the query set, and then because it's a distance object, you can put it in whatever units you feel like it. All right. Layer mapping in Django, there's a django.contrib.gis.utils, and layer mapping resides there. You do need Google for this to work, and it automates, I call the TDM, that goes into importing data from a spatial data source into a GeoDjango model. And basically, it's just incrementing over each layer in the data source, or each feature in the data source, and constructing the model from it. And you pass in a model and a dictionary mapping, and I'm going to show you an example here. Here's an example of the script I used to import all 33,000 zip codes of the United States into the spatial database. So you do the mapping dictionary is just you use the field from your model to correspond to whatever's in the shapefile. And here, and then for the geometry, you just specify what geometry type you want to use. You have to be in shapefiles in particular, they can sometimes say they're polygons, but they're really multi-polygons here. So this one, I say that it's a multi-polygon. And then you just pass it into layer mapping and then tell it to save. There's a lot more keywords that you can use and tweak, but this is kind of just a dead simple example. And it'll import all the data and put it into your spatial database. All right, we kind of covered this earlier. You can also add attributes on the admin here. So you can specify a default zoom level, default center point, a minimum zoom level, maximum zoom level, all as attributes like you would, like you normally do on admin classes. There's also the OSM GeoAdmin requires you to install the Google projection into your SpatialReference table, which will be in the docs. But if you don't want to use that, then you can also say have admin.geomodeladmin, which uses a simpler thing. But you don't get the OSM GeoAdmin is really good because you actually get a street layer there. The other one, it's very simplistic, so you don't get as much. Let's see if I can. Let's try it again. All right, here's the zip code we're in. And this is what I was talking about. You actually have the street layer. And on a nice slippy map. And this is actually an open, we're using open layers here and OpenStreetMap. And then you're able to actually select and manipulate all the stuff right in the normal admin. So it's pretty cool to be able to do this. Let's see. What? Oh, that's me. So yeah, and because this is also a multi-polygon, so this is the selection widget here, and then I can go to the add new one, and since it's a multi-polygon, I can draw myself a few new ones here. Hey, let's incorporate Sunnyvale here too. Get those Yahoo folks there. Bam. And then you can change back to this to drag around. So I owe a lot to Dane Springmeyer and Travis Pinney helped me out a lot getting this working, and it's very indebted to them for helping this out. And it's open layers too. I mean, that's why I like it so much, because it makes this type of stuff possible. you would never be able to do this before. So yeah, that's the geographic admin in action there. Let me go back to the presentation. All right. GeoFeeds and sitemaps. All right, this is a very new feature. I didn't actually think I was going to get this into 1.0, but due to Jacob's work on the feed class, I was able to actually get this in. So just like I said before, you would import feed from Django.contrib.gas to feeds, use it like the normal feed class, except this one has support for a geometry and item geometry method. So you would define either one of these for however you're doing your feed and make sure it returns the geometry that you want to do. And by default, it returns simple GeoRSS in the RSS format. There's also Atom GeoRSS, and you would just change the syndication. You would change the feed type to the Atom. It's called GeoAtom1 feed, I think, in the feeds module. And you would just change that, and then you'd have Atom feeds instead. And there's also an older type of GeoRSS that only supports points, but it's been around, and it was made by W3C. It's called W3C Geo. For those that haven't seen what a GeoRSS feed looks like, all right. It's basically attaches these. Let me see if I can find them. Too much stuff here going on. There it is. It's basically adds the namespace for this GeoRSS thing, and then adds in the coordinates for you automatically. So that's what it does, and that allows your whoever has GeoRSS enabled readers to put those on a map. You could literally have Google Maps just pull in this feed, and then it'll plots the stuff, or open layers will do the same thing, just plop all these points on the map and then create pop-ups automatically for them with the description and title. So it's just kind of a very simple way to syndicate your geographic content. Also, another upside is that Google actually now, when the bots are crawling, they actually take into account the geographic context. So it's, you get double bonus points there. Next are the geo sitemaps, which are kind of in the same vein. Wow, I really mucked that slide up. I literally just ripped out the URLs from my crime map site to kind of show you how you would do this. So I have KML sitemap, KMZ sitemap, and GRSS sitemap are all sitemap classes that you can use. And the way they work is that you can, if you just instantiate a KML sitemap, then it assumes all your models. Let me see if I can get this right. I don't know. I'll show you here in a second. And I'm adding views here for KML and KMZ. And boy, that really sucks. But what KMZ is just a compressed form of KML. And it's basically in a zip file, and GeoDjango can automatically render KMZ files as well. There's actually a shortcut render to KMZ, render to KMZ that you can use if you're so inclined. And what exactly does a geo sitemap do? It adds content. So basically, it adds this GeoGeo thing. This is an extension to the sitemap protocol that Google added recently. And so here I'm saying, here's where the beats are, here's where the Houston Police Department districts are, and then specifies the correct format so that Google knows how to crawl and add that special context to everything. All right, back to the presentation. All right. Whoops. All right. Future plans. We have all the documentation right now on geodjango.org. I'll be putting that when I polish up the text file some more into the SVN. The next spatial backend I'm going to be adding, believe it or not, is for SQLite. There's something called SpatialReference, and it actually has the same dependencies at Geos and Proj as PostGIS, and has more functionality than MySQL, believe it or not. And I just, especially since the guy's been developing it so quick and seems to be maintaining it well, I'm thinking I'm going to try and pick that up and try and add it. Another thing is Geodata Browse, which I did not have time to, we've actually made some progress on that front, or at least Dane Springmeyer has. I didn't have time to actually try out his code and show you, but that's going to be also on the horizon. And another big thing is geometry backends. So by default, all those geometry attributes on the models are Geos geometries. So you kind of get this you get this descriptor there that you can access all those methods on the Geos object that you want. The problem with that is that you're using Geos, so it means you got to have C types, which means you got to install this library, and that means it's a complete no-go for Google App Engine. So I've already laid the foundations so that there's actually, in the internals of the code, there's no I don't directly use Geos geometry instantiating it in the database internals at all. I have something called spatial backend at geometry. So it'll just be a matter of coming up with a protocol and then just swapping out whatever geometry class we have. And so for Google App Engine, we can theoretically come up with an all Python geometry class and then use some type of geohash point theoretically in the future. And also ORM enhancements, I mentioned subqueries and aggregates are things that I want to improve. And that's all I got. Yeah, exactly. So I'm glad to take any questions.
So I was always surprised when I first saw it that there was no GPX native support.
It does.
Okay.
Okay, because yeah, I was really harping on the shape files, but you can actually, with that data source, you can just feed it in a GPX file. And because Google supports GPX, you can read out of it. The layers are different, though. There's like 4 layers, so it'll be like the 4th layer instead of the 1st. So, yeah.
So for Django people.net, which isn't running on GeoDjango, but after this talk I really think it should be, I've got the problem that I've got 3,000 points, and I can't put them all on one map. So I was wondering if you've got any clustering stuff, or if there's anything in GeoDjango that can help with that sort of classic problem.
No.
No. That's a shame.
Yeah, he brings up a good point there. When you try and shove all this stuff into the JavaScript, it tends to break down. So there's been some addressing on the front. For example, Google Chrome completely revamped the JavaScript engine. And then there's the other option, which is the other trend I'm seeing, is a lot of people using Flash APIs instead to accomplish the thousands of points rather than killing everyone's browser. Okay. But I don't have any clustering algorithms, I'm sorry.
Is there support for, or is there planned support for things like in KML, there's like ground overlays, kind of like image overlays that are kind of combining image data with geodata, kind of like.
Right.
So is there any sort of support in like utility libraries for that?
Well, Google's actually more known for its raster support, and raster is a fancy name for image with some georeferenced information on it. And that's what it really does well. I don't really actually, in all of the public code, there's no interfaces to that functionality. I do have some in private code that I may release the interface for all that raster stuff, but that doesn't actually put anything into the KML files. What you can do, though, is with Django templates, it's really easy to create. You can extend upon the base KML template and then add in whatever image information that you want to for the ground overlays, for example. But I don't have any native support right now.
Piggybacking on Simon's question, do you know of any good algorithms? So not talking about a bunch of different points, but say you've got a line that's got 3,000 points in it, but maybe 1,000 of those points are pretty much like something to compress stuff like that. Do you know of anything?
You mean
like, so taking out, rather than saying, okay, I want to put 3,000 points in a line on a map, but these points are zigzagging, so I want to keep those, but these are kind of in a line, and I want to compress. These are strategically taking out the points that don't really affect like some sort of compression type thing.
Yes. Actually, there is. On the Geos geometries have a method on them called simplify. So you do geometry.simplify up to the tolerance of how much you want to do it. It uses something called the Douglas-Pucher line simplification algorithm, and it'll reduce the number of points on a line or polygon, for example. So playing around with that would be the easiest choice, and that would be on server side rather than client side. So.
Right. Okay. And if you don't mind, I had a couple other quick questions. So on GPX files, it seems like every GPS device throws out some crappy proprietary XML format. Are there any good libraries there that handle those?
There's the name. The name escapes me. There's a what? Yes. Is that the open source one? It converts all. It can enter. What did you say? GPS. Mapper? Yes, that's it. GPS Babel, yes. And it speaks all the formats of all those proprietary things, and then you can save it to a GPX and then use that GPX on with layer mapping and data source.
And then do you handle elevations?
That's something I should have put on the future thing. We don't have 3D support yet, but the spatial database supports it, but there's some problems with the GeoC API with 3D stuff. So there's actually a dimension keyword on the field that you can actually set to 3, but it's not gonna really work.
Cool. Thanks a lot.
Yeah.
2 questions. The first one is I went to your site and clicked on the document, and I don't see much documentation there. Is it under development?
Yeah, it is.
When you will have something like in a pretty good shape that we can actually use it?
Hopefully soon. I'm working. My goal is to have the install doc, the database API, the model API, the measure API. All that is almost completely documented. The thing that isn't is the tutorial and I have stubs for like the Geos, geometry, and the Google stuff is all stubbed out. Those are the biggest things. But the tutorial is the biggest missing link right now. Most of the other stuff, I've been updating it, in fact, this weekend, or actually this week, I should say, and it's coming along quite well. So I've on the wiki, I've officially moved the database API and the model API off the wiki and now to the website. So if you can contribute some patches, it'd be great. I actually have a Mercurial on geodjango.org, and there's a repository called GIS Docs with all the stuff in REST format, so I could gladly accept patches. So.
Second question says, do you have plans to support Facebook Connect, Open Social Connect, or actually Google Connect?
Is that the brand new thing that Google just came out with, or the location API?
Yes.
I don't have any plans, but I'm going to look into it now.
Okay, thanks. It's the social networking API.
Yeah,
No,
I don't have any plans yet.
So for those of us who are now convinced to convert their current site to a GeoDjango site, and we might have a lot of addresses that we want to add a geopoint to, and then somehow get that latitude and longitude. Do you have a...
Say that again?
You want to GeoDjangofy your current Django site, right? And you have
a
whole bunch of addresses in the site, and you want to add a geopoint to them.
Mm-hmm.
Do you have a recommendation similar to the GeoIP library that you're using there? I've tried. I have.
Oh, you mean geocoding?
Yeah.
Oh, okay.
So,
yes. There's something called GeoPy. It's like the de facto geocoder for Python right now. Unfortunately, it's not.
It's not accurate, right? That's the Tiger. Is that generally?
No. That's a different. GeoPy is an interface for like Google, Yahoo, Wiki. Wiki's got its own. Wikipedia's kind of got its own geocoder interface too. So it's kind of like a interface for those network protocols. As far as for Tiger geocoding, the closest thing right now is a Perl module called Geocoder US, and your mileage may vary on that, and how you interface it with Python is another story.
So is that something that's easy enough to do? You don't need an abstraction in GeoDjango itself to add?
You just do
a call.
import from geopy.geocoders, import Google Geocoder, and then Google Geocoder.geocode,
Cool.
whatnot.
Thanks.
Mm-hmm.
So basically, MySQL support sucks. Do you know if they have any plans to sort of catch up on PostGIS?
Yes, they do. And how far along they are, it depends on. I remember when I first was looking at this, they actually had the milestone set for full OGC support in 7.0, which who knows when that's coming out. But they've since moved that up to 6.0, and there's actually a Russian developer who came out with kind of like a beta release that supported some of the like actual real contains functionality and stuff. And so I downloaded it, compiled it, and tried it out, and it segfaulted. I segfaulted MySQL with my tests. So I filed a bug and just kind of, I knew it wasn't quite ready for prime time yet. I haven't checked back recently, but they do have plans. They are actively working on it. When it actually lands, I don't know.
Okay,
Mm-hmm.
thanks.
Okay, well, thank you very much, Justin Bronn.